Hello again. In the previous video, we connected function operations, composition, and inverses. Now we're moving into a new idea called quadratic functions. A quadratic function graphs as a parabola. So in this lesson, we're going to focus on vertex form because vertex form lets us quickly identify the vertex, axis of symmetry, and direction of opening. So first of all, let's look at the quick rules. A quadratic function has the form of f of x equals ax squared plus bx plus c, where a is equal to 0. A is not equal to 0. Vertex form is the one that we were working on previously. The vertex we found out in the previous lessons were h and k, and the axis of symmetry is x is equal to h. Now, if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. Okay, very important information. Now let's begin. So example number 1. For this equation here, it says we need to state these following things. So this function is already in vertex form, as you can see. Just to compare it with this vertex form here, this is our a parentheses x minus h squared plus k. Now, what we have to do is this. We have to separate fact from fiction. So we have 2 parentheses x minus 3 squared minus 5. So the value of h is 3, and the value of k is negative 5. So h is 3, and k is negative 5. Okay, so the vertex is 3, negative 5. Now, the axis of symmetry is the vertical line that passes through this vertex. So the axis of symmetry is going to be our x value. So the axis is x equals 3. Okay, so the axis of symmetry is the line that goes directly through your parabola. So this, in this case, the x would be 3. Okay, so the coefficient a is 2. Okay, so since it's positive, the parabola is going to be, it's going to open upward. Okay, so it's going to open up. Let's see. I need to just state that a is going to be equal to 2. Okay, so it's going to open up. That's very important. And since the parabola opens upward, the vertex is going to be at its lowest point. Okay, so the vertex is going to be a minimum. Okay, so just the final answer, we have a vertex of 3, negative 5. The axis of symmetry is x equals 3. This graph opens up, and then it has a minimum value of negative 5. Okay, I just forgot to put that, the minimum value of negative. All right, let's continue. Example number 2. Write the equation of a quadratic function with a vertex of negative 4, 2, and a multiplier of 3. Okay, so again, the function is f of x equals a parentheses x minus h squared plus k. So the vertex we're given is negative 4, 2. Okay, so this tells us that our h, k are these values. So what we can say is h is negative 4 and k is 2. And then we also have a already. A is 3. So we have everything that we need. Now we substitute these values into the vertex form. So here we essentially say this is going to be 3 parentheses x minus a negative 4 squared plus k. So it's going to be plus 2. Now, simplifying the double negative, we have 3 parentheses x plus 4 plus 2. Okay, so the final result would be this equation. Okay, the plus 4 inside means the vertex moves to the left, and so that matches the negative force shift there. Okay, pause the video and try the following problem. Okay, so this function here, negative parentheses x plus 1 squared plus 6. So essentially what we have to do is we have to rewrite this expression on the inside. It's plus, so we have to rewrite it as such. So x plus 1, and we essentially have to rewrite that as x minus a negative 1 so that we can understand what the h and k would be. So h in this sense would be negative 1, and then k would be a positive 6. So our vertex is negative 1, comma 6. Okay, and then the axis of symmetry is equal to x equals negative 1. Okay, that's our axis of symmetry. And then in this case, notice our coefficient is a negative 1. So that means that this graph is going to open downward. Okay, it's going to open like this, which means our vertex is at its peak, right? So the maximum value is going to be this. Maximum value of 6. So the graph goes down forever at y is equal to 6. So that makes the range essentially negative infinity with 6 being the cap here. Okay? All right, let's continue. Example number 3. Example number 3, we are going to look at, it says, rewrite this expression in vertex form by completing the square and then state the vertex. So first of all, we want to begin with this function, f of x equals x squared minus 6x plus 11. Now, what we have to do is we have to group the x squared term and the x term in order to complete the square. So the way that looks is this. We have parentheses x squared minus 6x plus 11. All we did was group them, okay? Now, after we group them, to complete the square, we take half of this value and we square it, okay? So what we do is, let's see, I'm going to take negative 6 divided by 2, which is negative 3. And then we're going to take negative 3 and we're going to square it. So that's going to give us 9. Okay. And so again, this is the completing the square process. So this is 9. So what do we do with this 9? We add 9 to both sides. Okay. So we add we add 9 and then we also subtract 9 inside the expression. So what this looks like is f of x equals x squared minus 6x plus 9 plus 11 minus 9. Okay. Then we can factor this perfect square. So this is a perfect square, and we can factor the perfect square trinomial. So this will be f of x equals x minus 3 squared plus 2. 11 minus 9 is 2. So now now notice the function is in vertex form, right? So we have our h, we have our k. So the vertex is 3, 2. So the vertex is 3, 2. So the vertex form is this as followed. Okay, that completes that problem. Let's continue. Example number 4. Use a point to find A. So for this problem, the quadratic function has a vertex of 2, -3, and passes through 4, 5. Write the function in vertex form. Okay, so first of all, we want to start with vertex form. That's f of x equals a parentheses x minus h squared plus k. So the vertex, it's already given. So we already have our h, we already have our k. So notice the h is 2 and k is -3. So essentially what we can say is f of x equals a parentheses x minus 2 squared minus 3. Now we're going to use this point because it says it passes through 4, 5. So we're going to use this point to determine a few things. So one point we have x equals 4, and then another one we have where f of x equals 5 here. Okay, so we're gonna solve for both of those things. So let's first of all solve for when the function is set equal to 5. So when it's 5, we have a parentheses 4 minus 2 squared minus 3, right? When that happens, we end up with 5 equals, let's see, that's going to be 2 squared. So 2 squared is going to be 4. So it's going to be 4a minus 3. We add 3 to both sides. So it's going to be 8 4a. So a is going to be equal to 2. Okay. Now we know what a is now. So we can really complete this right here, right? So we can substitute a into the equation. So this would be f of x equals 2 parentheses x minus 2 squared minus 3. So that would be our final answer. Now, a common mistake is students say that the vertex equals y equals x plus 5 squared minus 2, and so they write the vertex as such. Correct the mistake. Okay, so first of all, vertex form we can say is y is equal to a parentheses x minus h squared plus k. Okay. The expression x plus 5 can be rewritten, right? This x plus 5 can be rewritten as x minus a -5. Okay. So h is actually -5, not +5. So this is incorrect. So the correct vertex is actually -5, -2. Okay. So again, inside feels like the opposite. All right. Very good. Now, again, a lot to cover, but this was a very fun lesson. Make sure you review these over because they are very easy to understand. And make sure you watch this video a couple times because it's best to remind yourself of these rules. Okay. And again, thank you for watching.